Hi guys, welcome back to part 3. Now let's create a services directory and add a file called LLM_service.dart. Create a class named LLMService and add a private constructor using LLMService._parentheses. Then create a static final instance. I accidentally named it _instance while recording. Don't add the underscore. Keep it as instance so it can be accessed from outside the class. I'll correct it later in the video. Let's start integrating our first AI model, Gemini. Open your browser and search for Gemini API. The first result will be the official documentation. You can also search for Google AI Studio API key if you only need an API key. But for now, let's open the documentation. We're now on the Gemini Interactions API page. Click on the REST tab to view the curl request. A curl request is simply an example of how to call the API. It shows the request URL, request headers, and the request body. We also need to pass our API key in the request headers. The -H flag represents the request headers, while the -D flag represents the request body that we'll send to the API. Now, let's get our API key. Click on the Get API Key link at the top right. This will open the API Keys page, where you'll see a list of any API keys you've already created. If you already have an API key, simply click the clipboard icon to copy it. Otherwise, click the Create API Key button at the top right corner. A dialog will appear where you can either select an existing project or create a new one. For this tutorial, I'll create a new project called Multi-Chat. Click on Create Project. Once the project is created, enter a name for your API key. I'll name it Gemini API Key, Multi-Chat. Then, click the button to generate the API key. Your API key has now been generated. You can either click the clipboard icon or the copy key button to copy it. After that, close the dialog. Back on the API Keys page, you'll see your newly created API key listed at the top. You can always come back here and copy it again whenever you need it for future projects. Here, the documentation uses the V1 beta endpoint, but since the stable version is now available, we'll use V1 instead. Just like in the curl request, we need to pass our Gemini API key as the value of the XGoog API key header. I'll copy it again from Google AI Studio and replace the existing value in Postman. Next, we'll add another header called content type and set its value to applications/JSON. Now, let's move to the body tab. Select raw and choose JSON as the body format. Here, we'll pass the Gemini model along with the input, also known as the prompt, in JSON format. Also, make sure the request method is set to post. Then click the send button. Oh, it looks like the older Gemini models are no longer available for new users. No problem. Let's switch to the Gemini 3.5 Flash model and try again. Great, this time it worked. Now let's take a look at the response. Our response text is inside the steps array. First, we access the first element, then the content list, and finally the text field of its 0th element. That's where the generated response is stored. Whenever you're integrating a new model, always inspect the API response and verify where the response text is located. Different models or APIs may return different response structures, so make sure you're parsing the correct field. If the response format changes in the future, simply update your parsing logic accordingly. Now that our Postman request is working successfully, we can implement the same request in our Flutter code. Using Postman is a quick way to test an API before writing any code. It also has a web version, so there's no need to download the desktop application. Let's start by creating the Gemini API URL. Instead of typing it manually, we can simply copy it from Postman to avoid any spelling mistakes. Next, let's create a method called GenerateGeminiContent. This method will return a future string, since the response text is returned asynchronously. We'll also pass the user's prompt from our text field as a parameter, and don't forget to add the async keyword at the end of the method signature. Next, let's create a .env file in the project's root directory. We'll use this file to keep our API keys separate from the source code. Inside the .env file, create a variable called Gemini API key and paste your Gemini API key as its value. Let's go back to Postman, copy the API key from the request headers, and paste it into the .env file. We'll use the Flutter_.env package to load and access environment variables. Now, let's go back to our generate Gemini content method. Here, we'll access the API key using the .env.get method and pass the variable name we defined in the .env file. Before that, we need to load the .env file when the app starts. So, let's go to the main function. Convert it into an async function with a block body, and call the .env.load method. We also need to register the .env file in the pubspec.yaml file. I intentionally didn't remove the assets section earlier because we'll need it now. Add .env under the assets section. Save the file, and then go back to the generate Gemini content method. Now, let's create a final variable called response and assign the result of the HTTP post method to it. Before we can use the HTTP package, we need to import it and give it the alias HTTP. Next, call the post method and pass the request URL. Since post method expects the URL in URI format, we'll wrap our URL with the URI.parse method. Now, we need to pass the API key and content type as request headers in our code. Just like we defined them in Postman, we'll define them here as a Dart map. First, add the headers parameter. Then, add the xgoog API key header and assign it the Gemini API key variable. I'm using the variable name Gemini API key because later we'll also be accessing API keys for other LLMs. Next, add the content type header and set its value to application/JSON, just like we did in Postman. Now let's add the request body. Instead of typing everything manually, I'll go back to Postman, copy the JSON body from there, wrap it with the JSON encode method and paste it into the body parameter. Since we already set the content type header to application/JSON, the request body should also be in JSON format. That's why we use JSON encode to convert our Dart map into a JSON string before sending the request. Now, let's replace the input string with the prompt we received from our text field. Next, let's check the response status code using an if statement. If the status code is 200, it means the request was successful and everything worked as expected. We can then decode the response body using the JSON decode method. Now let's check the response structure again. Our response text is inside the steps array at index 1, then inside the content array at index 0, and finally in the text field. We need to follow the same path in our code to access the response text. So, from the decoded response, access steps, then index 1, followed by content, then index 0, and finally the text field. Return this value from our method. Finally, let's handle the error case. If the status code isn't 200, we'll return an error message along with the status code and the response body. This makes it much easier to debug API issues. Now let's create a try-catch block and wrap our API integration code inside it. If an exception occurs, we'll catch it and return an error message along with the exception. That's it. Our Gemini API integration is now complete. Let's close the other files and go back to the _ask method. Create a final variable called response and call our generate Gemini content method using LLMService.instance. Since we're using the await keyword, we also need to mark the _ask method as async. Okay, looks like there's an issue here. Let's check the LLMService file. I accidentally added an underscore to the method name. Let's remove it. Since it's private, we can't access it from outside the class. We're still getting an error. Oh, I found it. I also added an underscore to the instance variable. It shouldn't be private either. Let's remove the underscore. Now we can access LLMService.instance without any issues. Now, pass our prompt to the method and store the returned value in a final variable called response. Next, call setState and assign the response to the _response variable. Calling setState tells Flutter that the state has changed, so it rebuilds the UI and displays the latest response. Now it's time to run the app again. Otherwise, you might run into issues loading the env file. Clear the terminal and run Flutter Run. Great, the app is up and running. Let's search for what is Flutter. Now, click the button and wait for a few seconds. I forgot to add the progress indicator while recording this video, but I'll implement it later. Perfect! We got the response successfully. Now, let's enable the progress indicator. Before making the API request, call setState and set loading to true. After the API request completes, inside the existing setState call, set loading to false so the progress indicator is hidden and the UI is updated. Now, let's test it. Search for machine learning and click the button. Great. The progress indicator is now working as expected. That's it for part 3. I'll see you in part 4.